So in the previous video, we used the example of the Bic lighter to illustrate physical and chemical properties. Let's take that chemical property, that flammability that we saw at the end, and write it in the form of our very first, at least written in words, chemical reaction for this course, because we're going to use it to make a few points about chemical reactions, particularly the conservation of mass. So in that Bic lighter, when we flicked our Bic, we had our butane reacting with oxygen. So reactants are on the left-hand side of this arrow. When they react or combine to have a chemical change to produce new products, the new products that are produced, which are written on the right-hand side of this arrow, the products are carbon dioxide and water. So what I wanted to illustrate to you with this slide, aside from the parts of a chemical reaction, which is that when you have a chemical reaction, the stuff or the matter that is in it is neither created nor destroyed. What that means is that if you start with a certain amount of reactants in grams, in this case 266 grams, the amount of product that you receive better equal the amount of reactant that you started with. That's a fundamental property of the kinds of chemical reactions that we will talk about in this course, which is the conservation of mass. So mass is conserved in these reactions, and that conservation also applies to energy, because there's energy either absorbed or released when talking about chemical reactions. And whatever energy that is involved is conserved, just like matter is. So the rest of this chapter is going to talk about energy and its forms and how we're going to do some calculations regarding energy and temperature with respect to matter. So these are all types of energies that you have probably encountered in other physical science classes. The two types of energy that we are going to be focused on in this course in chemistry is chemical energy, which is a form of energy that's associated with the positions of atoms in a molecule. And then we're also going to talk about thermal energy. So that's energy associated with the movement or the motion of atoms and molecules in matter. And so you can probably imagine that the way that we study thermal energy in the chemistry lab is by measuring temperature. And we're going to talk about the scales for temperature and doing calculations with temperature in a future video. But let's first talk a little bit more in general about energy and some terms that are associated with when we talk about energy. When we talk about energy with respect to a chemical reaction, obviously it's conserved like mass. Energy in a chemical reaction is either absorbed or released. If a chemical reaction releases heat, like the form of the Bic lighter, when you see that flammability, it's releasing heat. If heat is being released, then we say that that is an exothermic process. Exo meaning released. So we say that the process is exothermic if heat is released. And we use this variable Q to denote that we're talking about energy. So if a process has a Q, has an energy that is exothermic, since it's losing heat, that associated heat, that Q, is going to have a negative sign associated with it. It means it has lost heat. Conversely, if a chemical reaction absorbs heat, for an example, a reaction on an ice pack, if that reaction absorbs heat, then that means that the process is endothermic, and the heat that is associated with that reaction has a positive sign associated with it. So these are two terms that you should be familiar with when talking about energy changes for a reaction. And in the next video, we're going to talk more about thermal energy and temperature.